Okay, so right now I'm going to teach the bus problem this time. So this is we're gonna do it in like a very simple method. It's called using LCM. So yeah. So what the problem was every 12 minutes, bus A completes a trip from P to X to S to X to P again. And then every 20 minutes, bus B completes a trip from Q to X, from Q to X to T to X to Q again. And then every 28 minutes, bus C completes a trip from R to X to U to X to R again. And then at 1 p.m., every bus depart for their first stop. And then they each also drive at relatively constant speed, and then they each turn around instantly at the endpoint. So each bus runs around until 11 p.m. So what they're asking is how many times between 5 p.m. and 10 p.m. will two or more buses arrive at X at the same time? And it's a multiple choice question, so there are five possible answers provided. So A is 18. Hold up. So A is 18, B is 19, C is 20, D is 21, and E is 22. Okay, so it sort of looks like this. So you have X in the middle, and then it goes like this: bus A, and then bus A is here, and then here are the other buses. So each bus has their own route, and then once they reach the end, they instantly turn around. Okay, so the solution to this problem is to find to find what times two or more buses are going to meet at X. We're going to have to find the LCM of their two coefficients from their expression. So for bus A, the expression for the times that bus A stops at X is 3 plus 6n. So we add 3 because it first arrives at X at the 3-minute mark. Since it takes 12 minutes to complete a full loop, it takes 3 minutes to get to the first X, since X is the second stop. Since yeah, X is the second stop. And then after that, X is the every second stop. X is the second stop after X. So first X is the second stop, and then after that, X becomes every second stop after another stop. So then it's every 6 minutes after the first 3 minutes. So then every time we loop back, we're gonna just add another n, and then that's 6 more minutes. Okay. So the coefficient is the number that is before the variable when you're doing multiplication. So bus A and bus B, they first meet at the 15-minute mark. So since the LCM, the lowest common multiple of 6 and 10, which are the 6 and 10 are the coefficients of these two expressions. Since it's 30, they're going to meet every 30 minutes after their first meeting. So 30 minutes after the first meeting. So their first meeting is 15. Then after their first meeting, it's going to be every 30 minutes. So then the next meeting is going to be at 45 minutes. So then bus A and C, they first meet at the 21-minute mark. So 21 minutes. So, and since the lowest common multiple of 6 and 14 is 42, that means they are going to meet every 42 minutes after their first meeting at 21 minutes. And then bus B and bus C, they first meet at 35 minutes. So then that means their coefficients, again, of their expression, their coefficients, lowest common multiple is 70. Okay. So then that means they're going to meet every 70 minutes after their first meeting at 35 minutes. Also, here's an expression for the first two, for the meeting like times which they meet at X. Bus A and bus B, they're going to meet every 15 plus 30x minutes. Okay, so then same thing for here. 21, so this 21 is their first meeting starting from 21, and then you add 42 minutes every time since it's 42 minutes every time they meet each other. So then you just multiply 42 by the number of times they're meeting, and then you'll just keep getting the amount of times. But then that means we also can't pick the number. We also have to only pick the times that fall between 5 p.m. and 10 p.m. So that means the domain is 240 minutes after 1 p.m. and 540 minutes after 1 p.m. So then bus A and bus B, their meeting times, according to this expression right here, their meeting times are here, 255, 285, 315, 345, 375, and so on. Remember, these meetings are only after 240 minutes. So then bus B and C, after 240 minutes, they meet starting from 245 minutes, 315 minutes, and then 385 minutes, 455, and then 525. Bus C to A after 240 minutes, 273 minutes is the first time they meet within the domain. And then again, it hits 525 minutes as their last meeting. So then we can only count the times that are circled in red. We can only count them once since it says 2 or more buses. So this only counts as one time where 3 buses meet each other at the same time. So then when we merge the duplicated times, we can create a final list where 2 or more buses meet at X. So then here's our final list. It's just the 3 of these merged together, and also these circled in red times, they only count once in the list. So we have 18 times, so you can count if you want, the 18 times in this list. So that means our final answer is A, which is 18. So yeah, that's the most simple way that I could think of to solve this. Okay.
Wait, can you go back to the last slide?
What? Okay.
Yeah, this part, like.
Yeah.
This
What?
part
Which
and, like, stuff.
part? This which?
Like the combining number LCM coefficient thingy.
This?
No, like the part where you have to find the LCM of the two coefficients of the expression thingy.
Oh. So you don't understand why we have to do that, or like the process?
The process.
Of finding the LCM?
Oh no. Like the why we have to do it.
Why we have to do it? Because The LCM, right? So you have 6 and then 10. So bus B arrives at X every 10 minutes. And then bus A arrives at X every 6 minutes. Okay. So then we're basically trying to find like when does every 10 minutes overlap every 6 minutes?
Oh, okay.
Hey, Kyler, so we basically count over the times that they overlap.
Yeah, at X, at stop X.
And the same goes for Y. You like use different variables to like describe.
Yeah.
Cool.
These are like this is the expression for like when they meet. Right?
Yeah.
So 15 plus 30, because the lowest common multiple is of these two, of 10 and 6 is 30, right? So then they meet every 30 minutes. They overlap every 30 minutes. So that's why we add 30. And then the X is there so that we can like just scale the 30. So the first time they meet, that's 30 minutes. Then we just increase X by 1. That multiplies the 30 by 2. Then it's going to be another 30 minutes. That's going to be the next time they stop.
So the variables like describe where they are.
Yeah.
Cool.
Simple? I think everyone understands. No other questions, right?
Yep.
Yeah. Okay.